What's up, people? This is your ninth assembly language tutorial, and in this one we're going to be writing the real code. So let's get started. Now, if the entire logic that I explained in the previous tutorial is clear with you all, I mentioned towards the end that we're going to be using something which is like a nested loop, and we're going to be working with one word at a time. All right. So if you see the values stored here, I have my AX register having the least significant 16 bits, right, of the result, because I added AX and CX, right? So that is having my least significant 16 bits, and BX is having my most significant 16 bits of the result right now. So keep that in mind. Let's get started. So a nested thing, the outer variable is gonna have the value 2, right? So let me just do that right now. Move DH comma 02. Why I'm using DH, I'm not using anything else. I'm just picking up any register, right? You can use anything you want, so that really does not matter. But you cannot use AX and BX because they're having a result, right? So we're not going to be interfering with AX and BX, but except that you can pretty much use whatever you want. Next, let's talk about the inner variable. The inner variable was supposed to be having the value of 4, so let me just make that CH 4. Alright. So this is my inner variable having the value of 4. Now let's go ahead. Next step, what we're going to do is I'm going to use a special instruction called roll px comma cl. Now if you look at the result that we have, which we need to display, we need to display this value 2 3 4 5 6 7 8 9 a, right? And right now, what does my BX have? It has the most significant 16 bits, so it has 2 3 4 5 in it, right? So I want the value 2 to be displayed first, right? So what am I doing is I'm rolling BX. Roll is for rolling BX comma CL. If you look at CL, my CL should also be assigned a value of 4. I didn't assign that. I'll just assign that right now. 4. Okay. So my CL also has a value of 4, and when I'm doing roll BX comma CL, I'm rolling BX by CL. So I'm rolling the value in BX by 4 bits. All right, or not 4 bits, actually 4 characters, not 4 bits, right? So I'm rolling the value in BX by 4 characters. So what that means is my 2 3 4 5 after the roll operation would become 3 4 5 2. All right, so if you were not rolling by 4 characters, and if you were rolling by, let's say, 3 characters, then your 2 3 4 5 would have become what, 3 4 2 5, if you can understand what I'm trying to say here. So 4 characters at a time means that your first value, which is 2, becomes the last value, right? The most significant bit becomes your least significant bit. Now, why am I doing this? Why the hell do I need the roll operation? Well, I'm going to explain it to you all right now. The next step after you roll it is you move the value in BL to DL. And what that means is, obviously, when I explained the registers to you all, I mentioned that BX is composed of BH and BL, right? So BX is a 16-bit register, BH is 8 bits, and BL is again 8 bits. So when I say BL, it stands for B low, right? So the lower half. And what that means is I'm going to be moving the value in BL to DL. All right, so what is the value in BL right now after the roll operation has been done? The value in BL is 52. All right, this is because BL holds the lower half of the number, right? So BL actually has 52 right now, and what we're gonna add after this is and TL comma OFH. Now what this is going to do is and move DL comma BL and DL comma OFH. What this does is it moves the lower half of the value in BL to DL and it selects the LSB. So DL comma OFH is for selecting the LSB. Alright, so you select the LSB. What value does your DL really have now? It has the value 2. Alright, now just try to understand what's happening here. Let's say I have my number 2, 3, 4, 5. Alright, and my 2, 3, 4, 5 actually got converted to, after the roll operation, 3, 4, 5, 2. Alright, and we selected 52, and the value that we got was 2, right? Finally, now repeat the same operation on 3, 4, 5, 2. 3, 4, 5, 2. After the roll operation will become 4, 5, 2, 3. Select 23 and select 3. So if you look at these values that I'm getting after each and every step, first I got 2, then I got 3. If I do this again, I'll get 4. Are you getting what I'm trying to say here? I'm getting the values that I need, right? So I'm getting the right values to print every single time. So the first time I do it, I get 2, the second time 3, the third time 4, and so on and so forth. We get the entire word 2, 3, 4, 5 printed on the screen. All right, so this operation, right, I roll it, I move DL comma BL, and DL comma 0FH selects the LSB from the moved value, and then we're just gonna print it, right? So again, having explained this part, it's really important to say here why I have used DL, for moving these values. And the reason I have used DL is whenever you call your AH comma 02H method, it's always going to print the value stored in DL, all right, which is sort of similar to the 09H function, which always looks in DX for the string, right? So DL is going to be having a value, and 02H is going to be looking in DL to print that particular value. All right, so this is the gist of the code that we're going to be doing. I'm going to stop in this tutorial. I'm going to go ahead and make another one for this so that I can explain the entire concept really carefully, and I don't want to rush into this one. So you got the gist of it. You move the value 4 to CH because we're dealing with, well, I'll tell you why we did that. You move, for now let's just look at CL. We move the value 4 to CL. We're rolling it by 4. We're after the roll operation has been done, we're selecting the value stored in BL, which actually has the least significant 8 bits, so 2 characters, and then we're selecting the least significant character itself. So this is how we're actually gonna get one value in every step which is required to be printed, right? So thank you guys for watching this one. I'm gonna go ahead and make another one for this real quick so that I can explain it